Welcome to GATE lecture. So today we will solve some problems related to Z transform. So let us solve some previous year GATE problems. So find out the Z transform, find out the inverse Z transform of xz, and xz is given as z square 1 minus 1 by 2 z raised to the power minus 1, 1 minus z inverse 1 plus 2z inverse, 1 plus 2z inverse, and the ROC is given that ROC is entire z plane, but it is not including 0 and infinity. So let us find out the inverse Z transform of this problem. So xz, just multiply all these terms, together. So what we will get here? We will get, after the multiplication, this is z square, then this is minus 1 by 2 z raised to the power 1. This z square is multiplied inside, so it is z square multiplied by 1 is z square, then minus 1 by 2 z raised to the power plus 1, and then 1 minus z raised to the power minus 1, and this is 1 plus 2 z raised to the power minus 1. So the resultant multiplication of this is we are getting z square plus 1 by 2 z minus 5 by 2 plus z inverse. So xz we are getting as z square, then 1 by 2 z minus 5 by 2 z raised to the power minus 0. We can say that it is plus z raised to the power minus 1, because z raised to the power minus 0 is equals to 1 only. So there is no harm in writing in this way. Now we can check what are the various coefficients. So let xn is equals to x0, then we have x minus 1, then we have x minus 2 up to this, and then we have x1, then x2, then x3, and up to this. So basically what is xz? By the definition of xz is equal to minus n is equals to minus infinity to plus infinity xn z raised to the power minus n. So highest negative power is basically this is for n is equals to minus 2, and this is for n is equals to 1. So what we are going to write in this way, that we start from n is equals to minus 2, and we will get z square, then x minus 1 z raised to the power 1 plus x0 z raised to the power minus 0 plus x1 z raised to the power minus 1 plus x2 z raised to the power minus 2. Now this is xz. Now this is equation 1 and this is equation 2. So we can compare equation 1 and 2. So by comparing equation 1 and 2, so by comparing equation 1 and 2, we compare the equation 1 and 2, we obtain the x minus 2 is equals to, so here we have 1, so x minus 2 is equals to 1, then we have x minus 3 that is equals to 0, and x minus 4 up to x minus infinity it is 0. So and what is x minus 1? So x minus 1 is equals to 1 by 2, then x0, so x0 is equals to minus 5 by 2, then x1 is equals to 1, then x2 is equals to here we have x2 is equals to 0, because here we don't have any z raised to the power minus, so basically there is no coefficient, so we can write it in this form. So x2 is equals to 0. Also from 2 to infinity it is 0. There is no channel, there is no coefficient, there is no coefficient. So finally what we are getting, we can write xn as, so we can write xn as, so xn we can write as 0, it is 0, 1, 1 by 2, minus 5 by 2, then 1, that's 0, and so on. So basically put arrow here, so this arrow position will tell that this is n is equals to 0, then right hand side of this arrow is, it is n is equals to 1, this is for n is equals to 2, this is for n is equals to minus 1, and this is for n is equals to minus 2, this is n is equals to minus 3. So here we are going negative n, here we are going positive n, positive values of n in this direction, and this is the reference point, that is n is equals to 0. So we can plot xn, we can plot xn. So at n is equals to 0, the value is minus 5 by 2. At n is equals to 1, the value is 1. At n is equals to 2, the value is 0. At n is equals to minus 1, the value is half. At n is equals to minus 2, the value is 1. At n is equals to minus 3, the value is 0. So this is our xn, this is our xn with respect to n. So basically this is two-sided signal and it is non-causal signal. So it is non-causal signal, and also it is also we can say that it is finite interval signal. So the ROC is entire, the ROC is entire Z plane except Z is equals to 0 and Z is equals to infinity. So both these points are not included. So we are writing ROC as 0 is less than modulus Z less than infinity. So this is the ROC. This is the ROC. This is the reason of convergence. Now let us solve another problem, and this problem is related to the long division method. This problem basically we are using the long division method to find out the inverse Z transform. So let us discuss the problem. So basically we are using the power series expansion method. So by using the power series expansion technique, by using the power series expansion technique, find the inverse Z transform, find out the inverse Z transform of xz. Find out the inverse Z transform of xz, so that xz is equals to 1 divided by 1 minus az inverse, and that modulus z is greater than modulus of a. Second one is xz is equals to 1 divided by 1 minus az inverse, and the modulus z is less than modulus a. So we have this question, we have this problem, and that solution we have to find out by using the partial series expansion technique. Now how to do this problem? So let us consider the first case, that is xz is equals to 1 divided by 1 minus az inverse, and this is given that the ROC is modulus of z is greater than modulus of a. That means it is talking about the causal signal, it is talking about the right high-sided signal, because the ROC is exterior of the circle. So this problem basically, this problem belongs to right-sided signal, because the region of convergence is exterior of the circle. Region of convergence is exterior of the circle. Modulus of z is equals to modulus of a. Because this is modulus of z greater than a, it means this is exterior to the circle. Modulus of z greater than a means this is exterior to the circle. So this is imaginary part of z and this is real part of z. So this is exterior to the circle. Now we can find out by using the power series expansion method. We can find out by using the power series expansion method. So xz is given as 1 divided by 1 minus az inverse. Now if it is a causal sequence, if it is a causal signal, then please write in this way. Just write 1 minus az inverse, and here 1 is inside, so we are going to divide 1 by 1 minus az inverse. So we have to get 1, so if we multiply this whole term by 1, then we will get 1 minus az inverse. Then applying the basic mathematical rule, this 1 will cancel out, then we will get az inverse. So what we will do, we will multiply with az inverse, then we will get az inverse minus a square z square minus 2. Then applying the basic rule, again it will cancel out, so it is a square z raised to the power minus 2. Then here we are going to multiply with a square z raised to the power minus 2, and we will get a square z raised to the power minus 2 minus a cube z raised to the power minus 3. And this process will continue, so finally what we will get here, this process will continue. So what we will get here, the x that xz is equals to 1 plus az raised to the power minus 1 plus a square z raised to the power minus 2 plus a cube z raised to the power minus 3 plus a4 z raised to the power minus 4, and so on. So basically this is basically infinite GP. This is basically the infinite GP series. So how to find out that value? So first thing is clear that xn is equals to 0 for n less than 0. That first thing is clear. Second, because we don't have any power that belongs to z raised to the power, that we don't have any coefficient for z raised to the power 1, z raised to the power 2, because if we see here in this expression, it is only containing the negative powers of z. So since xz is only containing the negative powers of z, so we can say that xn is equals to 0 for n less than 0. Now what are the various coefficients? So x0 is equals to 1, x1 is equals to a, x2 is equals to a square, x3 is equals to a cube, and xn is equals to a raised to the power n. So what is xn? So xn is nothing but a raised to the power n un. We can write in this form. So it is basically xn is basically a raised to the power n un. From this, why we have multiplied by un? Because it is a causal sequence, and only it is perfectly causal sequence, and it is only that value xn is equal to 0, because when we have n less than 0, that's why we have multiplied with un. So this is the solution of part A. Now we can do the solution for part B also in the same manner, so but some slightly different approach. So we have xz that is equals to 1 minus az inverse, and this ROC is modulus of z is less than modulus of a. So basically this signal is talking about, this signal is basically the non-causal. This signal non-causal because the ROC is interior of the circle. The ROC is interior of this circle. Modulus Z is equals to modulus A. So the ROC is interior of the circle. So we have circle, and that ROC is basically interior of the circle. It means that it is basically that it is non-causal. It is non-causal. In fact, it is anti-causal. In fact, it is anti-causal signal. So that approach will be slightly different. And how to do that long division? So instead of writing 1 minus a z inverse, we are going to write minus a z inverse plus 1. The same thing is there, but we are writing in this way so that we will get the positive powers of z. Why we are writing this in this way? To get the positive powers of z. Now 1 is here. How? By which factor I will multiply so that I will get 1, so that 1 will 1 with 1 cancel out. So what is that? We can multiply with minus a inverse z raised to the power 1. And when we are going to multiply it, then we are getting 1 here, and this is minus a inverse z raised to the power 1. So this will cancel out. So we are getting a minus 1 z raised to the power 1. Then we are going to multiply with minus a raised to the power minus 2 z raised to the power 2. So when we are multiplying with this, so we will get a inverse z1 and minus a minus 2z2. So this process will continue. And finally we are getting that xz. So xz we are getting is minus a raised to the power minus 1 z raised to the power 1 minus a raised to the power minus 2 z raised to the power 2 minus a raised to the power minus 3 z raised to the power 3 minus a raised to the power minus 4 z raised to the power 4. So this is xz. This is xz. Now what is x0? So x0 is 0 for n greater than or equal to 0, because this is a non-causal signal. Since this is a non-causal signal, so we have xn is equal to 0 for n greater than or equal to 0, and x minus 1 is equal to minus a raised to the power minus 1, x minus 2 is equal to minus a raised to the power minus 2. Similarly, x minus n is equal to minus a raised to the power minus n. So finally, if we write that xn, then it is nothing but it is equals to minus a raised to the power n u minus n minus 1. So this is our xn. This is our xn by using the partial by using the power series expansion method. So by using the power series expansion method, we are getting minus a raised to the power sorry, this is yeah, here we did some mistake. So we have, let me check. We are getting xn is equals to minus a raised to the power n u minus n minus 1. So if we compare the coefficient, then we can find out that xn is equals to 0 for n greater than or equal to 0, because it is a non-causal signal, and x minus 1 is minus a raised to the power minus 1, x minus 2 is minus a raised to the power minus 2, and x minus n is minus a raised to the power minus n. So thus we get xn is equals to minus a raised to the power n u minus n minus 1. And since the ROC is interior to the circle, so basically we have modulus of z is less than modulus of a. Now let us solve some problems. Let us solve some problems. Like problem A is we have xz, and that is equals to log 1 divided by 1 minus az inverse, and that ROC is modulus of z greater than modulus of a. And the problem B is xz is equals to log of 1 divided by 1 minus a inverse z, and that ROC is modulus z is less than modulus a. So these two problems we have to solve. So let us solve these two problems. So the problem A is, so xz is given as log 1 divided by 1 minus az inverse, and that ROC is modulus of z is greater than modulus of a. And now we can apply the formula for log 1 minus r, that is log 1 minus r is equals to minus summation n is equals to 1 to infinity 1 divided by n r raised to the power n, 1 divided by n r raised to the power n. So we can use this formula. Now how we are going to use this formula, let us discuss that point. So since that we start from ROC, since mod z is greater than modulus of a, it means that we have az inverse should be less than 1. We have modulus of az inverse should be less than 1. Now what we are going to do, that xz is equals to minus, just we are applying this minus summation n is equals to 1 to infinity, we have 1 by n az inverse raised to the power n, and that is equals to summation n is equals to 1 to infinity 1 divided by n a raised to the power n z raised to the power minus n, and that is nothing but it is equals to if we just analyze that, then xn is equals to 0, xn is equals to 0 when we have n is less than or equal to 0, and it is equals to 1 by n a raised to the power n when we have n greater than or equal to 1. So when we have n greater than or equal to 1, we have 1 divided by n a raised to the power n, and when it is n is less than or equal to 0, we have xn is equal to 0. Now let us do the another problem. So we have xz, and that is equals to log 1 divided by 1 minus a inverse of z, and that ROC is given, the ROC is given as modulus of z is less than modulus of a. Now log 1 minus r is equals to minus summation r is equals to 1 to n is equals to 1 to infinity 1 divided by n r is to the power n. We are again applying this formula. but slightly different way because the ROC is different. So since we have modulus of z is less than modulus of a, so we have modulus of z by a is less than 1, so it is a inverse z should be less than 1. So this is the condition now. So xz can be written as summation n is equals to 1 to infinity 1 divided by n. So it is written as minus 1 to infinity, n is equals to minus 1 to n is equals to minus infinity 1 divided minus 1 divided by n, a raised to the power n, z raised to the power minus n. Because this is a non-causal sequence, so it is from minus 1 to minus infinity, that value is exists, that some coefficients are existing, and from n is equals to 0 to infinity it is equals to 0. So because we have considered the ROC, that is ROC is modulus z is less than modulus a. So if we just analyze this expression, so what we are getting here that xn is equals to 0 when we have n greater than or equal to 0, and it is equals to minus 1 by n a raised to the power n u minus n minus 1. Please understand that when we have n less than or equal to minus 1. So finally that xn is equals to minus 1 divided by n a raised to the power n u minus n minus 1, and the ROC is modulus of z is less than modulus of a. So the xn is minus 1 divided by n a raised to the power n u minus n minus 1, and the ROC is modulus of z less than modulus of a. So let us discuss another problem. So the problem is using the power series expansion method. Using the power series expansion method. Using the power series expansion method, find the inverse Z transform. Find inverse Z transform of xz is equals to z divided by 2z square minus 3z plus 1, and the ROC is modulus of z is less than 1 by 2, and second part is xz is equals to z divided by 2z square minus 3z plus 1, and the ROC is modulus of z greater than 1. So let us solve this problem. So it is z divided by 2z square minus 3z plus 1. So what we are going to do, we can find out that z transform set. So the first question, that z transform, that ROC is given, that is modulus of z is less than 1 by 2. So we can apply the long division method to find out the inverse z transform, and by using the long division method we can easily find out the inverse Z transform. So let us do this problem by using the partial in the long division method. So we can write, since it is a non-causal signal, so we can write it in this manner, just reverse order we are writing. So it is 1 minus 3z plus 2z square, and we have inside we have z. So first we will multiply with z, and we will get z minus 3z square plus 2z cube. Then it will cancel out, and we will get 3z square minus 2z cube. Then we have multiplication of 3z square. Then we have 3z square minus 9z cube plus 6z raised to the power 4. Then we have 7z cube minus 6z raised to the power 4, and this process will continue, so xz is written as z plus 3z square plus 7z cube plus 15z raised to the power 4 plus dot dot dot. Now this xn, if we say that only the positive powers, so only the positive integers of z is there, so that xn is just we can write it as 15, 7, 3, 1, 0, and the arrow is there. So that starting position is basically the first coefficient is 0, and we have z raised to the power 1 here, so at n is equals to minus 1 we have 1, then we have 3, and further calculation we have 7, then we have 15, and rest all the points are equals to 0. That's all, rest all the points are equals to 0. So this is our solution, this is our xn. Now we can solve the part B also. So the part B is that xz is equals to z divided by 2z square minus 3z plus 1. So it is z divided by 2z square minus 3z plus 1, and the ROC is modulus of z greater than 1. So we can again apply the long division. So it is 2z square minus 3z plus 1, and here we have z. So let us start doing that. So first we multiplied by 1 by 2 z inverse. So what we will get z minus 3 by 2 plus 1 by 2 z inverse. So it is minus plus minus. So what we will get here, we will get 3 by 2 minus 1 by 2 z inverse. Then we will multiply, then we will just multiply it by 3 by 4 z raised to the power minus 2, and we will get 3 by 2 minus 9 by 4 z raised to the power minus 1 plus 3 by 4 z raised to the power minus 2. So this is minus plus minus, and it is cancelled out. So we will get 5 by 4 z raised to the power minus 1 minus 3 by 4 z raised to the power minus 2, and so on. So this process will continue. So xz is equals to 1 by 2 z raised to the power minus 1 plus 3 by 4 z raised to the power minus 2 plus 7 by 8 z raised to the power minus 3 plus dot dot dot. So the xn is equals to 0, comma 1 by 2, comma 3 by 4, comma 7 by 8, comma dot dot dot. So this will continue. So this is our xn. So basically that treatment is different. We are writing in this way when we are going for causal signal, because it is a causal signal. And when we have non-causal signal, then we are just writing in reverse way. So instead of writing 2z square minus 3z plus 1, we will write that as 1 minus 3z plus 2z square. Just we are reversing the order. We are writing in reverse order. So let us do another problem. And that problem is also belongs to finding out the inverse Z transform. So let us do another problem. So the problem is we have xz, and xz is equals to z divided by 2z square minus 3z plus 1, and the ROC is modulus of z is less than 1 by 2. The ROC is modulus of z less than 1 by 2. So the xz is equals to z divided by, we can just write in the factored form. So it is 2z minus 1, then z minus 1 by 2, and it is equals to modulus of z less than 1 by 2. So we just using that xz divided by z, doing the partial fraction analysis, and it is equals to c1 divided by z minus 1 plus c2 divided by z minus 1 by 2. Now we can find out the value of c1 by c2. So c1 is equals to 1 divided by 2 z minus 1 by 2, when we have z is equals to 1 and it is equals to 1. So c2 is nothing but it is equals to 1 divided by z minus 1, when we have z is equals to 1 by 2 and it is equals to minus 1. It is equals to minus 1. So xz by z, we are writing xz by z equals to 1 divided by z minus 1 minus 1 divided by z minus 1 by 2. So what we are going to do here, yz is nothing but z divided by z minus 1 and then minus z divided by z minus 1 by 2. So and the ROC is modulus of z less than 1 by 2. So if we just taking the inverse Laplace transform, then yn is equals to minus u minus n minus 1 plus 1 by 2 raised to the power n u minus n minus 1. So xn is just so xn is basically we have xn, and we can write it in the form 1 by 2 raised to the power n u minus n minus 1 minus u minus n minus 1. So we have sorry, this is yn. So we have this yn, we can take that common, u minus n minus 1 we can take common, and this is the final solution. This is the final solution. So this is x. So the final solution is xn is we are getting xn as 15, 7, 3, 1, 0, and this is the arrow. This is the arrow. So basically this is non-causal. There is no term in right hand side. Only we have negative positive powers of z. Please see here, there only positive powers of z are there. So we don't have any negative powers of z. So this is basically the non-causal sequence. This is basically the non-causal signal. This is non-causal signal because no negative powers of z is present. No negative powers of z is present. There is no negative power of z that is present. So this is the solution. This is the solution. Let us do another problem. So the problem is similar. We will find out the inverse z transform. So xz is given. So xz is written as z divided by z minus 1. Then we have z minus 2 whole square, and the ROC is given as modulus of z greater than 2. This is the ROC. So the problem is xz is equals to z divided by z minus 1, z minus 2 whole square. Now we can write xz divided by z as 1 divided by z minus 1 z minus 2 square, and it is equals to c1 divided by z minus 1 plus c2 divided by z minus 2 plus c3 divided by z minus 2 square, and it is written as equation number 1. Then what is c1? So c1 is 1 divided by z minus 2 square at z is equals to 1. So what we will get here? We will get 1. So this is equation number 2, and C2 is so let us find out C3 first. So C3 is 1 divided by z minus 1 at z is equals to 2. Please check this, and it is equals to 1. So this is equation number 3. Now C1, putting the C value of C1, putting the C1 and C2 in 1. So using C1 and C2 in 1, what we will get? We will get basically the equation we will get is 1 divided by z minus 1 z minus 2 square, it is equals to 1 divided by z minus 1 plus lambda 1 divided by z minus 2 plus 1 divided by z minus 2 whole square. So finally just setting z is equals to 0, setting z is equals to 0, we obtain what we are going to obtain is minus 1 by 4 is equals to minus 1 minus lambda 1 divided by 2 plus 1 by 4. So lambda is equals to minus 1. So lambda is equals to minus 1. So we are getting lambda is equals to minus 1. So xz is written as z divided by z minus 1 minus z divided by z minus 2 plus z divided by z minus 2 whole square. So what we will get, and this ROC is modulus of z greater than 2. So that xn we are getting is, please check that xn we are getting is, since it is a causal sequence, so we are writing 1 minus 2 raised to the power n plus n 2 raised to the power n minus 1 into un. Okay, so this is our inverse z transform of this xz. This is the inverse z transform of this xz. This is inverse z transform of this xz. So xn is equal to 1 minus 2 raised to the power n plus n multiplied by 2n minus 2 raised to the power n minus 1 into un. So this is the z transform. So this is the inverse. This is the inverse z transform of xz. This is the inverse z transform of xz. That is xn is equals to 1 minus 2 raised to the power n plus n z 2 raised to the power. So this is 2 raised to the power n minus 1 into un. This is n only. So this is xn. Now let us do another problem. So we can find out the inverse z transform. We can find out the inverse z transform of, find the inverse z transform of xz, and that is equals to 2z cube minus 5z square plus z plus 3 divided by z minus 1, z minus 2. And the ROC is given as modulus of z less than 1. So this is the ROC, that modulus of z less than 1. So how to do this type of problem? First, we have to check that whether the degree of numerator is greater than denominator or it is less. So here we are going to we can see that the degree of numerator is higher than denominator. So first we have to perform the division. So since numerator degree is greater than denominator degree, so first we are going to perform division. So what we are going to do, we are going to perform the division. So it is 2z cube minus 5z square plus z plus 3, and here we have z minus 1, z minus 2, so it is nothing but z square minus 2z minus z plus 2, so it is z square minus 2z minus, so it is z square minus 3z plus 2. So we are going to perform the long division. So it is z square minus 3z plus 2. So what we will get here, we will get after the performing the long division. So if first we have to multiply with 2z, so what we will get here, we will get 2z cube minus 6z square plus 4z, then it is minus plus minus, so it is z square minus so it is minus 3z plus 3, so z square minus 3z plus 3. So after this we have to multiply it with 1, so better to write in next page. So okay, I am writing the final answer. So we have after multiplying with 1, so we will get, so here I am writing, so z square minus 3z plus 3 after multiplying with this, so we get z square minus 3z plus 2, so this minus plus minus everything will cancel out, we will get 1 here. So finally what we will get, we will get xz is equals to 2z plus 1 plus 1 divided by z minus 1, z minus 2. So this is our long division. After this is our result after getting after the division. Now this can be written as x1z. This can be written as x1z. So what is x1z? So x1z is 1 divided by z minus 1, z minus 2, and by using the partial fraction analysis we can do that. So we can write c1, we can do the partial fraction analysis for that. So before that what we can do, we can divide x1z by z. So before that we can divide x1z with z, so we will get 1 divided by z minus 1, z minus 2, and it can be written as c1 divided by z plus c2 divided by z minus 1 plus c3 divided by z minus 2. Now applying the partial concept of partial fraction, the c1 we are getting is 1 divided by z minus 1, z minus 2, and we have z is equals to 0. So we will get 1 by 2. Then c2 we will get as 1 divided by z minus 2, and we have z is equals to 1, so it is equals to 1, and c3 is equals to 1 divided by z minus 2, xz is equals to 2, so it is equals to 1 by 2. So c1 is 1 by 2, C2 is 1, C0 is basically C1 is 1 by 2, C2 is 1 and C3 is 1 by 2. So substituting the values of C1, C2 and C3, what we will get? We will get xz is equals to 2z plus 3 by 2 minus z divided by, please check this. Only I have substituted the values of C1, C2 and C3 in the previous question expression, and what we will get is 1 by 2 z divided by z minus 2, and this ROC is modulus of z less than 1. So finally that if we take the inverse Laplace transform, since it is a non-causal signal, so we are getting 2 del n plus 1 and plus 3 by 2 into del n plus 1 minus 2 raised to the power n minus 1 into u minus n minus 1. Please check this. Please check. This is the final answer. So this is the value of xn. This is the value of xn. So what is xn? So xn is 2 del n plus 1 plus 3 by 2 del n plus 1 minus 2 raised to the power n minus 1 u and u minus n minus 1, and the ROC is modulus of z less than 1, and the ROC is modulus of z less than 1. So let us do another problem. So it is also related to inverse Z transform. So find inverse Z transform of xz is equals to 3 divided by z minus 2, and that modulus of z is greater than 2. So let us find out the inverse Z transform. So xz is equals to 3 divided by z minus 2, and what we can do, we can find out the z common. So we can find out z common, and it is equals to 1 minus 2z inverse. And now this we can written as 3z inverse divided by 1 minus 2z inverse. Why I am doing this I will tell you later, because it will help in solving the program. So this problem. So basically we have 3z inverse 1 divided by 1 minus 2z inverse. We can write in this manner. So let us do that. Let us solve this. Let us solve this portion. So the inverse Z transform, that let it is x1z. So x1z is 1 divided by 1 minus 2z inverse. So x1n is basically it is 2 raised to the power n un. Now if we multiply with z minus 1, then what we will get? We will get shift of minus 1. So xn is equals to 3. Basically here we are going to shift with minus 1. So it is 2n minus 1 un minus 1. So this is our answer. This is our final answer. So we have used that property of z0 raised to the power z raised to the power minus z0 raised to the power minus n. That property we have used. So we have just used the property that z raised to the power minus n0 xz, the inverse z transform is xn minus n naught. The inverse z transform is xn minus n naught. So we have used this property. So xn is 3 multiplied by 2 raised to the power n minus 1 into u n minus 1. So this is the inverse Z transform of this problem. Now let us do another problem. So the problem is find out the inverse Z transform of xz is equals to 2 plus z raised to the power minus 2 plus 3z raised to the power minus 4 divided by z square plus 4z plus 3, and the ROC is modulus of z greater than 0, and ROC is modulus of z greater than 0. So what we are going to do here, let x1z is 1 divided by z square plus 4z plus 3. So it is equals to 1 divided by z plus 1 plus z plus 3, it is equals to this. Basically if we find out x1z divided by z, then it is equals to, so basically if we find out x1z divided by z, so let us find out x1z divided by z, and that is equals to, so x1z divided by z is written as z divided by z plus 1 z plus 3 into z. So here we are this z will cancel out, so it is equals to 1 divided by z plus 1 z plus 3. This is x1z divided by z. So the problem is xz is equals to 2 plus z raised to the power minus 2 plus 3z raised to the power minus 4 divided by z square plus 4z plus 3. Then after that we have written xz in this form. We can write in this form, and let this 2 divided by z square plus 4z plus 3, this portion is x1z, and x1z divided by z is written as 1 divided by z plus 1 plus z plus 3, and that is nothing but it is equal to c1 divided by z plus 1 plus c2 divided by z plus 3. So it is equal to c1 divided by z plus 1 plus c2 divided by z plus 3. So finally that we can find out the value of C1 and C2. So C1 is 1 divided by Z plus 3, and when we have Z is equals to minus 1, and so it is equals to 1 by 2, and C2 is equals to 1 divided by Z minus 1, and Z is equals to minus 3, and it is equals to, if we put z is equals to minus 3, then what we will get, so it is z plus 1, so what we will get, it is equals to minus 1 divided by 2. Please check this. If we put z is equals to minus 3 here, then it is equals to minus 1 by 2. X1z divided by z is, we can write it as 1 by 2 multiplied by 1 divided by z plus 1 plus minus 1 by 2 multiplied by 1 divided by z plus 3, and x1z is equals to 1 by 2 z divided by z plus 1 minus 1 by 2 z divided by z plus 3. So x1n we can write it as minus 1 raised to the power n minus 1. This x1n is written as 1 by 2, we can put outside, so it is equals to, minus 1 raised to the power n minus 3 raised to the power n into un. Please check this, because it is the causal sequence. It is given because the ROC is given at modulus of z greater than 0. The ROC is given as modulus of z greater than 0. So we have this relation x1n, then what is xn? So let us discuss what is xn. So x1n we have calculated, and x1n is equals to 1 divided by 2 minus 1 raised to the power n minus 3 raised to the power n into un. So this is this is x1n, so it is 1 by 2 minus 1 raised to the power n minus 3 raised to the power n un. Now what is xz? Please see that the xz is basically we have 2z raised to the power minus 1 plus z raised to the power minus 3 plus 3z raised to the power minus 4 multiplied by x1z. Now this xn is equals to, if we just take the inverse Laplace transform on both sides, then xn is equals to 2 x1 n minus 1 plus x1 n minus 3 plus 3x1 n minus 5. Now we can put the value of xn minus 1, xn minus 3, xn minus 5 by using this relation. So xn is equals to, just I am summarizing these terms, I am summarizing all these terms. So please check the calculation. So this is minus 1 raised to the power minus 1 by n minus 3 raised to the power n minus 1 un minus 1 plus 1 by 2 minus 1 raised to the power n minus 3 raised to the power n minus 3 un minus 3 plus 3 by 2 minus 1 raised to the power n minus 5 minus 3 n minus 5 un minus 5. So this is our final answer. This is our final answer. So this is our final answer. Let us do another problem. So this problem is xn is provided and xn is 1 1 1 1. Xn is given and hn is also given, that is 1 1 1. So hn and xn and hn is provided. Now find yn. Find yn. So this type of problem we have solved in discrete time LTI system, but here we are going to solve by using the Z transform. So Z transform is, we have xz and we have yz. So yz is equals to xz multiplied by hz. Now what is xz? So xz we can directly write here, it is 1 plus z raised to the power minus 1 plus z raised to the power minus 2, because by default we will consider it as a causal sequence if we don't have any information given, prior information is given. Similarly here we have 1 plus z raised to the power minus 1 plus z raised to the power minus 2. Then yz is nothing but it is equals to multiplication of these two signals. So what we will get here, we will get 1 plus, please check this relation, 1 plus z 2z raised to the power minus 1 plus 3z raised to the power minus 2 plus 3z raised to the power minus 2 plus 2z raised to the power minus 1 plus minus 2 minus 3 minus 4, then 1 into z raised to the power minus 5. So this is our relation. So in short we can write it as 1, then we have 2z raised to the power minus 1. So we have this is y0, this is y1, then y2 is 3, then y4 is also 3. So this is basically this is for 1, this is for 2, this is 3, and y4 is 2, y4 is 2, and then y5 is 1. So we have this is y0, y0 is 1, then this is y1, so y0 is 1, y1 is 2, y2 is 3, y3 is again 3, y4 is 2, y5 is 1. So we have 1 2 3 3 2 1. So this is yn. We have this is y1. So this is 1 comma 2 comma 3 comma 3 comma 2 comma 1. So this is yn. This is yn.